Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In this class, we will learn about sedimentation analysis. In our previous class in index property, we have already learned about sieve analysis. We do this sieve analysis method for coarse aggregate, right? So, as fine aggregate is very small or minute in nature, so we can't do the sieve analysis in that case. Like in sieve analysis, what happen? Fine grained soil will create one bond between them. So to separate them, so there will be some issues will create. So we can't operate that sieve analysis for fine grained soil. So for fine grained soil, we have sedimentation analysis. Okay. So sedimentation analysis is carried out for what? Soil fraction having size less than 0.075 mm. That is our 75 micron or the soil passing through 75 micron sieve. So what happens in case of sedimentation analysis? Like particle having size less than 0.2 micrometer, that will be our 0.0002 mm, cannot be analyzed even in case of sedimentation analysis. Okay, as that will be very small, the 0.2 micrometer. So in sedimentation analysis also we cannot operate sedimentation analysis for this small amount of soil. So for soil size less than 0.2 micrometer, we will use what? Electron microscope and X-ray diffraction technique, right? When soil size is very small, that will be 0.2 micrometer to very small than 0.2 micrometer. So we use electron microscope and X-ray diffraction technique. So sedimentation analysis, in sedimentation analysis what happens? It is based upon Stokes law. So yeah, so according to which the particle undergoes settlement within infinite medium. Okay. So in case of Stokes law, what it says, like particle will undergo within infinite medium. So the medium will be infinite. Okay, and it will depend upon size, shape and mass of the particles. Right. So in Stokes law, what happens? One is it will stay within infinite medium and it will depends upon size, shape and mass of the particle. So the formula for Stokes law is here. Like we will calculate the velocity here. So the velocity will be gamma s minus gamma w. So what is gamma s and gamma w? Like we represent gamma as unit weight and gamma s is your unit weight of solid, right? You can write here our gamma s is unit weight of soil solid and gamma w is unit weight of water. Which water? The water present in soil, the water present inside soil mass, right? Here d square is what? D for particle size. Okay. Right. And another term is 18 mu. Mu we use for dynamic viscosity. So here we got the formula for Stokes law. If gamma s is not given, we have g minus 1 gamma w into d square upon 18 mu. Okay. So this g is what? Specific gravity. Right? Specific gravity of soil. So, and our mu is dynamic viscosity and d is for particle size. Okay. So, here we got the formula for Stokes law, but When we apply Stokes' law, there will be some pros and consequences. So we have limitations of Stokes' law here. Okay, so the first limitation will be like particle undergo settlement is assumed as spherical. Okay, so what it says, like in Stokes' law, it says that the particles should be spherical in size, but in actual, the particles are flaky in nature, like the bond between them is very low, so that will be broken easily. Here, fine grained particles are flaky in nature, right? And the second limitation is what? The medium in which settlement takes place is assumed as infinite. Okay. The medium assumed as infinite. But what happens? When we consider this sedimentation technique, we take one sedimentation jar. So that jar has finite dimension. Here, we take one sedimentation jar. So that jar has finite dimension, right? Next is what? The particles is assumed to be undergo discrete settling, right? But in actual, fine grained particle aggregates during the settlement. So what it says? It says like, well, before the sedimentation process, the particle assumed as that will undergo discrete settling. What is discrete settling? Like the individual particles will settle individually. Okay, but in case of in case of fine grained particles, what happens? During settlement, it separates. Before the settlement, what happens? They have created their bond. So also this is wrong, also this is wrong, right? So all the assumptions we take in case of Stokes' law, that is going to be wrong little bit, right? So Stokes' law is valid for particles having size range between 0.2 mm to 0.2 micrometer. That will be also 0.002 mm. Okay, that means what it says, the particle size should lies between 0.2 mm to 0.0002 mm. Okay. First, what we have said, like in case of 75 micron, what the soil particles passes through the sieve of 75 micron, so that soil considered for Stokes' law. But here only this to this we can calculate the velocity, or we can consider the sedimentation process here. Okay, so what happens if, what do we say, like 0.2 to 0.0002 mm soil only can considered for sedimentation process or for Stokes' law. But if the size is greater than 0.2 mm, what happens? So there will be some turbulent motion. So that turbulent motion cannot give us actual velocity. Like that velocity will fluctuate. We cannot get constant velocity if the size of soil is greater than 0.2 mm. Here, turbulent motion, as a result of which constant velocity is not achieved throughout the settlement process, right? So if this is most important question, okay, so what happens if size is greater, there will be turbulent motion. Okay, greater than what? Greater than 0.2 mm, right? So if size is smaller than 0.2 micrometer, that is 0.0002 mm, so what happens? There will be Brownian motion setup which doesn't allow settlement of particle. As the particle size is very minute in nature, so in case of Brownian motion, that doesn't allow the particle to settle down. Okay. So here your next question arises will be size is less than 0.0002 mm. So one Brownian motion will be there, right? We need to remember these two terms. Okay. So for what turbulent motion and for what Brownian motion, right? So next is what? What are the procedure for sedimentation analysis? In case of sedimentation analysis, it is carried out by one pipette method, another one is your hydrometer method. Okay, so method of preparation of soil suspension is same in both these method, like pipette method and what hydrometer method. So the soil preparation is same, but we do some pre-treatment. So first we will do some pre-treatment before conducting this pipette method and hydrometer method. Before preparing soil suspension, okay, soil suspension is what? When soil settles down, that will create some bond between them, and that will that is weak in nature, but they will conduct bond formation of bonding between them. Okay, so what happens before preparing soil suspension? We need to remove the organic matter and calcium compounds. Organic matter and calcium compounds present in soil should be removed. Okay, in order to avoid the aggregate of solid during settlement. Okay, as what happens? Avoid aggregation. Aggregation was what? Separation. Okay, so if there is presence of organic matter and calcium compound, so they will separate. So we need to remove that organic matter and calcium compounds. So how we will remove that? So organic matters are removed by oxidizing agent like H2O2, our hydrogen peroxide. Okay. So to remove oxidizing agents, we will use hydrogen peroxide. As to remove the organic materials, we will use oxidizing agent like hydrogen peroxide, right? And to remove the calcium compounds, we will use HCl, that is our hydrochloric acid, and 0.2 N. Okay. So next is what? The soil passing through 75 micrometer sieve is mixed with water. After we remove the organic matter and we will remove the organic matter and calcium compounds. Then what we will do? We will do the test by the soil passing through 75 micrometer sieve. We will take and add it with water to prepare standard volume of soil suspension. Okay, so in pipette method 12 to 30 grams of soil we will take and add it in water, and in hydrometer method, here you can see in pipette method 12 to 30 grams of soil, and in hydrometer method 24 to 60 grams of soil will add it in water for preparation of 1000 ml of soil suspension, right? So we have conducted the pre-treatment and the procedure. Now what the post-treatment? So after preparing suspension dispersing agent, what are the dispersing or deflocculating agent? When added in to prevent what? The flocculation of solid during the settlement. So as the bonds will form in case after pre-treatment. So to deflocculate, we will use some dispersing agents. So what are the dispersing agents we use to deflocculate them? Here the commonly used deflocculating agents are sodium hexametaphosphate. The best one is sodium hexametaphosphate, sodium carbonate, sodium oxalate and sodium phosphate. These are some deflocculating agent we need to what? To stop them for the formation of or aggregation between them. Okay. So here in this class you have learned about the sedimentation analysis process for fine aggregate soil. As in our next classes we will learn some more new topics. Okay. So thank you so much.